Hi guys, we're going to start off with an activity this morning, and I wish to goodness I was with you because you would all be getting Hershey, and it wasn't COVID. I'd be giving you all a bunch of Hershey Kisses. So you need to have opened, if you don't already, the lesson 8.2 day 1, which way will the Hershey Kiss land? We're going to start off with this worksheet. So you need that in front of you. If you need to pause me and get that in front of you, do so. Okay. So let's go into it. Okay, when you toss a Hershey Kiss, it's Christmas time, so I found a bag of the Christmassy looking one, Hershey's. Okay, it'll sometimes land. Let's see, get this on its side, or it could land on its flat end. Okay. And so we want to ask, what proportion of tosses will land flat? If we were in the classroom, each one of you would be in groups of 4, and you'd be tossing them these Hershey Kisses, and you'd be keeping track of what proportion landed flat. Unfortunately, due to COVID, we can't do it exactly like that. So I have Hershey's Kisses right here on my desk. I got out a random sample from Target, a bag bought at Target, and I have 50 Kisses sitting here now. Okay, I'm going to toss them on my desk, and I'm going to toss a bunch at once and just let them, we'll see how they land. All right, but that's the idea. You can see some of them are up, right side up, some of them are sideways. Okay, I've done this a couple of times. What we do in the class is we would have everybody, we'd have like multiple different groups, since there's 24 of us. We have 6 different groups who would be doing this and get maybe a different p-hat, right? P-hat being the proportion of your sample that landed upright. So for our purposes for this worksheet, yeah, it's sharing my screen, right? Yeah. For the purposes of this, we're going to let our point estimate be 0.42, because 21 of these little things landed on their flat side. Okay, so if you'll put in there 0.42, what I'm going to have you do now is pause the video and go and complete the rest of this. What was the population parameter sample statistic? You can talk to those around you if we're in class on Thursday when this is going on. I'm taping it Tuesday. Hopefully you'll still be in class on Thursday. And fill in all the way down to number 7. Okay, you know how to answer these questions that I'm rolling through here. What's the formula for standard deviation? What condition must be met to use that formula? And we don't know P, so we're going to substitute p-hat in that. So calculate the standard deviation, and then you'll have to check NP, and N times 1 minus p-hat, of course, because that's what we're using. Okay, and then I want you to do question number 8, and this one is a new one, okay? And this is going to lead us into what we're going to learn in the notes today. You remember that, within a normal distribution, 95% of the data lies within, hopefully you remember the 68, 95, 99.7 rule. 2 standard deviations is 95% of the data. So 2 standard deviations of the mean. That value 2 is called a critical value, which I'll go through more in notes, okay? You can either use table A or inverse norm on your calculator. I highly recommend inverse norm. It goes very quickly this way. I want you to find the critical value. So now you think about it. For the first one, 80% of the data lies within how many standard deviations of the mean? Well, if you got a middle 80% and you're going to the z-score, you look at that left tail, and how much is in that tail? Well, if 80% is in the middle, then that means each tail has 10%. So as you go from left to right, the tail is 10%, right? So you want to find the z of 0.10. And you go inverse norm. I showed you there the example inverse norm 0.10. That'll get you the critical value. Although that's going to be negative because you're below the mean. We don't want the negative value. We just change that value to its opposite. It's always a positive critical value, like 2 standard deviations away, or 1.5 standard deviations away. That means, we don't say it's negative 1.5 standard deviations away unless we're trying to talk about specifically where that data point is in location to the mean, above or below. Okay, but right now we're just trying to get a general idea. 80% is within how many standard deviations of the mean. 90% is within how many. Find those 4 critical values, okay, and then move on to numbers 9, 10. We won't be able to do 11. 11 would have been very cool, and I'll come back to that and show you an example of what it would look like. So you're just working all the way through 10 to find a 95% confidence interval, and we'll talk what that means too. But follow the instructions of what it says to do. I'll come back and give you some answers to these in a second. Okay, so this is going to take you a while. All right, we're back. So remember I said that p hat was 0.42. Here's what your population and your sample is, and what's the parameter. It's the true proportion that land flat. Our statistic was 0.42. Was the sample random? Yes. Remember that condition is very important. We cannot generalize to the population unless it was a random sample. Here's your formula, the 10% condition. So we're assuming that we know that 50 is less than 1/10 of all kisses. Okay, there's more than 500 of these chocolate kisses that'll probably be sold in, good grief, in matters of minutes at the stores around Christmas time especially. All right, so that will be met. There's your standard error. Check and see if you got that. It's also called the standard deviation of the p-hats is called the standard error. Okay, also. So there you have it, and then you did your large counts. Check that you did your large counts. Now here's where you should have gotten these critical value numbers as you worked. Remember, you've got, if 80% is in the middle, 10% is in each tail, and you're doing inverse norm of the tail to get these various numbers. So this would have been a 5%, this would have been a 0.025, and this is 0.005. Okay. All right, and then here's what we get with the margin of error. If you take the 95% critical value, which is 1.96, and multiply that by your standard deviation, you get 0.137. So this is now your margin of error. It is your critical value times by the number of standard deviations you are away from the mean. This is what a standard deviation exists of, and this is how many away it is. Okay. So then finding a 95% confidence interval is that point estimate plus or minus your margin of error. Okay, so it's that point estimate we did with p hat, 0.42, and then this margin of error that we got. Now, had we all been plotting, this is just an example, what could have happened? We would have had everybody's confidence interval here put onto a scale, and everybody would have put their point estimate in the middle and seen where it went. If the true proportion of Hershey Kisses that land flat is 35%, okay, then we would see how many of these people captured that true percent in their sample. And this person over here did not capture it at all, but everybody else, barely right there, but everybody else was able to say, yeah, within this range is the true proportion of kisses that would land flat somewhere in here. But we're with 95% confidence, so that means sometimes we're going to get an interval that does not capture it. This is just the N2 activity to get us ready for notes. The notes will explain this better if you're feeling a little bit confused from this. So let's get into the notes. Yeah. If I can get this to start. Presenting. Oops, it went to the other slide. I don't want it over there. I want it here. I guess I won't be presenting. We'll be doing it from here. All right. All right. So this is what we're going to do this chapter. We're constructing confidence intervals for the parameter proportion. We don't know it, but we're going to try to figure out. I think it lies within here, and here is the truth, and here's how confident I am. This is the percent confidence that I am. Okay. So we're talking in one sample Z interval. So we're just taking one sample. We're not taking two yet. We'll do that soon when we get the difference of proportions. But one sample Z interval for that population proportion is just what we just did. We took the p hat and we plus or minus, and then this Z star, which we're going to talk about a little bit more, that's that critical value that we did. That stands for what percent of the area lies between that negative Z and that positive Z on the normal curve. Okay, And so then this is just your standard deviation formula you've already been using from chapter 7. Okay, we know that there's 3 conditions that must be met to use the formula. Okay, so the first condition is that this has to be random. We've talked about that. And you have to check that it's been random. Lots of times it's given in the problem, or it could be a random phenomena. Okay. Then the large number counts. This is where we can only use Z, normal distribution, if it meets our large number counts, which we talked about too. Okay. And then the 10% condition says I can use my standard deviation formula. And that's that where your sample is less than 10% of your population. Okay. Again, we've talked about those. So before you construct a confidence interval, you must check those 3 conditions. Okay. All right. And then I'd already mentioned this earlier, but when you're taking the standard deviation of a statistic, like we were of like a p-hat, okay, then that result is called the standard error of the statistic. So you will see that language as well as the standard deviation. So in AP statistics, confidence intervals come in this form. Your point estimate, which is your p-hat, or it'll be X bar when we get to means, from your sample. Okay, that's where you start. And then you have a margin of error that goes around it. And you say, I am 95% confident that the true proportion will be within these numbers, in this interval, within this range. Okay, and here's another equivalent form that you'll see. It's that statistic, p-hat or X bar, plus or minus that critical value, which is your Z star. We call it Z star. Z star is French. Okay, no, the Z star is your critical value. And then you multiply that by your standard error, which is that standard deviation formula of the statistic. And that gives you your margin of error. Okay, so just remember, you have to check these 3 conditions: random, 10%, large counts. Okay, so let's do a problem with it. Here's Mr. Buckley's class. He wants to construct a confidence interval for the true proportion of red beads in a container that has 3,000 beads. So the class sample, there's in your book, this was done in your book. There's a class sample of 251 beads that had 107 red and 144 other beads. So we need to check the conditions to see if we can do a confidence interval for P. So remember, your first one is random. Okay, they took a random sample of 251, so we can check that. But you don't just go random check. You have to put words that explain that you checked, that you understand it was random. The 10% condition, this is that independence also. Remember, we're talking about these are random, independent, random samples. And since we don't have replacement, the 10% condition must be checked. And there's 251 beads will be less than the 10% of 3,000. It's less than 300, so we're good. And then your large counts, do your NP and N times 1 minus P. They're both the same, greater than 10. Okay, so we have our 3 conditions. Now we need to figure out, well, how do I get that critical value? You just practice that. So I'm going to go quickly on this slide. But here's where you get 95% confidence interval. That means that in the middle is 95% of the data. That means 5% is out in the tail. So you have to divide that 5% by 2. So that means 2.5% is in each tail. And here it is as a decimal, 0.025. So what you want to do to find that Z star, we'll get the negative one by doing it. The easiest is just go and either on table A or in the inverse norm calculator command and figure out what is the Z value to have 0.025% or 2.5% of your data in that tail. Okay, so there's just how to do it within table A. You find that negative Z value, okay, and then we change it to the positive. Or we should talk about using your technology. You just did that in the activity. They talk here how you have to also put in 0 and 1, but as you saw in my shortcut, the default is 0 and 1, so I just don't take time to type them all in. But again, you would get 1.960. You'd get a negative, but you change it to positive. Okay. Now, what's really interesting is you can also use table B. I'm trying to figure out if I could figure out how to pause this and pull up a table B for you. I forgot to get one ready. This is not allowing me to pause. I either have to stop or... So I'm not going to stop it. I'm going to reduce this. Not that. sorry guys, and go to see if I can pull the t-table real quickly. I apologize for not having that ready. Forgot about this. It's kind of funny. It's not the Z table that you would go to. It is the T table. And that's why I said table B, not table A in your formula sheet. If you go to it, you'll see when you get to down here that yours, I think, says infinity. As this gets larger for T-table, and I will explain T-table in another chapter coming soon, but if you look across the bottom, you will see these numbers right here should look pretty interesting, close to what you just now were doing in the worksheet. So you could find here, if you get the 80%, you look here at the Z to infinity on your table, and so 80% went to 1.282, here's 90%, 95. 95 is the most common, so most of the times we're going to just have memorized that the critical value is 1.96. Okay, so let me get back to our PowerPoint. Oops. PowerPoint. There we go. No, it's not. There we go. That's letting me know. Okay. Wrong one. There we go. So that's what it's talking about here about looking at table B, the T table for this. Okay. All right. Sent me back to the top for some reason. All right, there's where we were, getting our critical values. All right, so let's take another look at a problem, okay? Here you have 73% of American adults have read a book in the previous 12 months. This was based on a random sample of 20 American adults. Assume the conditions are met. So now we're not going to have to go do the conditions whenever they say that. But we need to determine the critical value for 90% CI and then construct a 90% CI, call it CI confidence interval, for the proportion of all American adults who have read a book. Okay, and then interpret that interval. So this is very important. This is, I'm almost certain AP test is going to ask this kind of a question. They always do. So using table A, or using inverse norm, we get the Z star. I'm not going to spend much time on that. But here's your point estimate, your p hat, plus or minus your critical value, Z star, for 90%, times it by your standard error or your standard deviation of the p hats that we've already been practicing, and you'll come up with this confidence interval. So we're 90% confident that that true proportion falls in that interval. And that's exactly how we interpret it. This is how you will start every single confidence interval answer. We are 90% confident that the interval from 0.711 to 0.749 captures, well, that should say, I'm not sure why it says P5. Sorry about that. P hat, P, no, it should just be the P. The true proportion, that should be an equal sign there, I think, of American adults who have read a book in the previous 12 months. Notice the context is there. You're also using the 90% confident, and you're saying it goes from here to here. You can also answer it in percentages if you want, where we are 90% confident that the true proportion or percent of American adults who have read a book in the previous 12 months is between 71.1 and 74.9%. That's another way to interpret it. All right, so to do these confidence intervals, you have a 4-step plan. State, plan, do, conclude. Ms. Straub's been harping on that. Remember, you're going to state the parameter that you want to estimate and the confidence level. You're going to state your procedure there. We're doing a 1 sample Z interval right now. 1 sample Z in. And the reason we say that is because that's what you'll see on your calculator as well, but it's called a 1 sample because there's only 1 sample of data. We're doing a Z interval. We're going to learn later how to do T intervals. So then you're going to plan your conditions, right? And you're going to then do the calculations and then interpret like we just did. So there is a attached worksheet on your Canvas page that gives you a template. State the parameter you want to estimate. So it tells you here's what you should state, parameter statistic, what you're doing, Okay, your confidence level you're using. In your plan, what is your procedure? Right now it's one sample Z interval. We're doing confidence intervals. Check your conditions. That's all under plan. Then your do. Here, you don't have to list the general formula, but if you do list the general formula, then you can go off and do your work, or you can put it specifically with the values in the formula. But there's their do, and you come up with an answer, which is the interval. But then you need to interpret that interval, and that interpretation is going to start with we are, and then blah, blah, blah. 90% confident, whatever your CI was. Okay, that document right there just gives you a model to follow as you're doing your homework and working through these problems. And so, okay, almost there. Okay, we're going to do one more activity 2 here pretty soon with an applet that's on your Canvas. Okay. Here's another problem. We're going to do the 4-step process with this problem. Recent poll of 738 randomly selected cell phone users found that 170 of the respondents admitted to walking into something or into someone while talking on their cell phone. So construct and interpret a 95% confidence interval for the proportion of all cell phone users who would admit walking into someone or something while talking on their phone. Okay, so here's your state. You're doing a 95% CI. I like to always say I'm constructing a 95% CI for P. We're identifying the parameter, which is the true proportion of all cell phone users, blah, 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 putting it in context, okay? Exactly like it's there. State what you're doing and what your parameter is, okay? Now your plan, here's your procedure, a 1 sample Z interval for P. Okay, this is all we're doing right now. So you're going to be learning a whole bunch of procedures. This is your first one. So right now, that's not a hard one to answer. Here are 3 conditions. Random. It told us they were randomly selected. 10%. We're going to assume that 738 is less than 10% of all cell phone users. I'm certain. Large counts. Okay, then you do your NP and your N times 1 minus P. Which here it was given to us in already. They already did NP. They already said that the proportion. So you don't have an actual proportion here. You're given the numbers. So this is tricky at times too. This is your NP 170. Okay. And then subtract that would be your failures. 1 minus P times N would be the 568. And both of those are at least 10. So in each group you have at least 10 items. Okay. So that's a good example for seeing one where we don't have a proportion actually given to us. We've been given a number instead. Now you could have gone and done 170 out of 738, right? And gotten your proportion. But then when you times that by 738 again, you get back to 170. Okay? Here's your do, which is what we just talked about. 170 over 738 is that 0.230. Now, your confidence interval is that P hat plus or minus Z star for 95, Z star for 95% is 1.96. And then there's your P times 1 minus P over N. And you get this interval, okay? So you finish, that's where you've got your answer, that you know the true proportion lies somewhere in there with 95% confidence. So we conclude we are 95% confident that the interval from 0.2 to 0.26 captures the true proportion of all cell phone users, and you put the context there. So those are your steps: state, plan, do, conclude. Okay? And it just says here in a free response question, if it asks you to construct and interpret a confidence interval, it doesn't say do the 4-step plan. You are expected to do the entire 4-step process. It is a requirement. You're to know to do that, even though it doesn't say do the 4-step plan. Okay? And you have to clearly identify your parameter, your conditions, all of that. If it just says construct and interpret, then you do the 4-step. Sometimes it'll say if conditions are met, then you could just say conditions are met. You don't need to go and identify all of them. Okay? One more caution. Remember that the margin of error in a confidence interval only accounts for sample variability. It does not account for if I had bias in my questions, or if I had non-response, or if I had, it doesn't account for any of that. That is assumed when we come to the table, that the researchers have gathered their data without bias as best they could. Now, this margin of error has nothing to do with that. It has nothing to do with any other types of biases. It only has to do with the fact that we have sampling variability, like these kisses. If you guys were here and everybody was tossing them, unfortunately, you couldn't do that. But if you were here and we were tossing them, each one of us would have had a different p-hat. So our confidence interval would have had variability in it. Okay, so that's why we get a margin of error, because it basically moves around and we're trying to capture the truth. Okay, so be very careful with that. That's why samples have to be taken carefully before it comes to this step. All right, let me get that put away, and then now you go back to the back of your worksheet. This is taking a long time to save. I'm sorry. Well, maybe I could just pull this up. That we were doing the Hershey's one, okay? And let's go to the back of it, where you're going to do your check your understanding. So I'd like for you to look at this problem here. I want you to identify the parameter, check the conditions, find your critical value, and then calculate the CI and interpret it. So basically this is leading you through the 4-step process for a problem. Do that and then come back and check with me on your answers for this, and we're done for the day. All right, you're back to check your answers. Let me put these up here for you to do a quick check on. All right, your parameter, hopefully you make sure that you put P. When we get to means, you're going to put mu. You have to determine if it's a proportion or a mean. So this is the true proportion, and there's your context. Always have context from the problem. Here's your 3 conditions: random, 10%, normal, which is your large counts. Okay. All right, and then the critical value for 98%. Okay. Hopefully you may have even had that on the other side of this worksheet already done, but you're going to go do inverse norm for 0.01 and get 2.326. Okay, now calculate the interval. Remember, that's p hat plus or minus your critical value times the standard deviation, and get your interval. Did you get that interval? Check and see. Okay, I'm going to have you put it in Edpuzzle before you come back to this, so I'll know if you got it right or not. Okay, we are 98% confident that the interval from 0.444 to 0.516, so there's how we started. We are 98% confident that the interval from 0.444 to 0.516 captures the true proportion of all adults who report that they often or always get enough sleep in the last 7 days. Okay, now you can also say we are 98% confident that the true portion, blah, 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 is between 0.444 and 0.516. Okay, but always start off with we are 100% confident that, and then make sure you're saying that we have a confidence interval that will capture that true value. Okay? All right, do your homework tonight, and I'll have another video for you tomorrow.